Thank you. Yes, the sine at 120 is square root of 3 over 2. Positive, right? What about the tangent at 120?
Negative
Square root of 3 over 2 divided by negative 1/2, so I have to flip the bottom. That comes out to be negative square root of 3. Sine at 120. Oh, wait, why is this there? That's the same thing we just did, didn't it?
Square root of 3 is negative 1/2.
Good. Sine is the same as sine. Okay. That's redundant. I don't know why that question's there. Okay. All right. So that one's if it's on the unit circle, it kind of follows suit. You just find it, and you're good. Number 2, this one, okay, you see square roots of 55. That is definitely not on the unit circle, is it? So we're going to have to do some thinking, use some logic here. So, I need to figure out what quadrant this is in. All right, so cosecant is related to what, x or y?
X, Y.
It's y, isn't it? It's a reciprocal of y. It's a reciprocal of sine, so it's a reciprocal of y. So this is telling me, notice I have a negative right here. That's telling that y values are negative. All right? So as I'm trying to figure out where is this triangle, I know it's not going to be in quadrants 1 or 2 because y values are positive. Yeah? Then I look at this other clue they gave me. Tangent is y over x, right? We just said that y was negative. We know that. So what does x have to be if my tangent's negative? Well, the x's have to be positive, which means it has to fall down in here, doesn't it? So that's how you're going to locate your triangle. Your angle theta is always going to be the angle there with the origin and the x-axis, all right? Always. So now you're going to use what they gave you. I would start with tangent here, because tangent is y over x. And we already just said that the y part we know is negative. So y is negative square root of 55, and x is a positive 3. So what would I do to find the hypotenuse? Yeah, good old Pythagorean theorem, right? So that'd be 9 plus 55 equals 64. So what is my hypotenuse then? 8. That means my hypotenuse is 8. Now I just have to find what it's asking me. Okay, now it's asking me, okay, what is the cosine? Well, the cosine is always adjacent over hypotenuse, right? That's on your chart. If you don't remember, it's right on chart. Adjacent to theta is 3. The hypotenuse is 8. Okay? I'm going to skip this one for a second because it's really weird, but you'll see how it works in a second. Okay, secant is hypotenuse over adjacent. So in this case, it would be 8 over 3. Right? See how we did it? They could ask you any of the trig functions. You just have to find the triangle, find the missing side, and then find the ratios. All right? Now, what if it does this to you? If it asks you, okay, cotangent of 90 minus theta. What the heck is 90 minus theta? Well, look at this. You're using the same triangle you used before. If you look at this triangle, we know that this angle right here is our right angle, isn't it? And this one is theta. All right, that means that this angle, how could we find this angle? 180 minus 90, which is 90. 90 minus this theta would give me this angle right here, wouldn't it?
Yep.
So that notation of 90 minus theta means, okay, change your perspective. Pretend your new angle is here now. You're starting here. And it's asking you, relative to this angle, it's asking me what? Cotangent? Cotangent is adjacent over opposite, right? So what side is adjacent to this angle right here? This one. What side's opposite this one? This, right? and then you just build the ratio. So this becomes negative square root of 55 over 3. So all it's asking you to do is just change the angle from which you're addressing adjacent and opposite. Does that make sense? Yes, can you handle it? Thank you. Next type looks like this. Basic trig questions. You did this type in geometry where you're given one side and one angle and you got to find the others. Okay, these aren't on your unit circle, so you're going to go back to like opposite, adjacent, hypotenuse sides. Okay, so you want to label based on your angle that you're given. The 12 is my opposite side, right? This is adjacent, not add, adjacent. And this one's the hypotenuse. So the first thing it's asking me to do is find x, find the adjacent side, right? So if I want to find the adjacent side, this is my unknown. I need a ratio that includes this side and this side. So which of the trig ratios uses opposite and adjacent? Tangent, good. So I would write an equation that looks like this. I would say the tangent of 30, opposite 30 is my 12, adjacent is the missing side, right? So I'm going to just do algebra now. I'm going to multiply both sides by x. Then divide by the tangent of 30. So don't separate the 30 from the tangent because that's a number together. Okay? So x will be whatever I get in my calculator when I do 12 divided by the tangent of 30. So let's look at our calculators and see what we get. Make it a fraction, 12 divided by tangent of 30. Of course, I'd want to make sure it's in degree mode. So it's 20.78, whatever that is. Whatever units, I don't know. So 20.78. That's that side. So now we know that this is 20.78. So theoretically, you could use Pythagorean theorem to find your hypotenuse if you wanted. Or just use a different trig ratio. So if I want to use a different trig ratio relative to 30, which trig ratio would use opposite and hypotenuse? Sine. Yep, sine. So I would do sine of 30 is opposite over hypotenuse, which we're calling r. And we do the algebra to solve for r. Don't separate sine from 30 because those go together. So then I would just put this in my calculator. 12 divided by the sine of 30 and get my answer. Okay? This is really similar to what we just did. So, easy peasy. 24. Are you okay with that? So just using trig ratios in different ways. Now, lastly, word problems. You're going to have to draw a picture, write the equation, find the solution. This is all geometry, but it's been a minute since you did it. So look, you are flying a kite that's making an angle of elevation with the ground of 42 degrees. So here you are. You're flying a kite that's way up here. Okay? There's your kite. Angle of elevation means you're looking up. Okay? So it's the angle with the ground. It could say angle of depression, which means you're looking down, and it would be the angle of looking down. Okay? So if this is 42 degrees. It says the length of the kite string is 500 feet. So this is where that would go. What is the height of the kite? This is the piece I want to know, the height of the kite. So which two sides you got? You were saying it. Opposite and hypotenuse, right? So I'd write the equation. I would say the sine of 30 is equal the unknown times 500, right? I don't know why I did 300 there, but that should be 500. All right. So could we do that in our calculators pretty simply? Yeah. You just multiply both sides by 500 and you have your solution. So 500 times the sine of 30 is the height of the kite, whatever it is. Okay? So draw the picture, look at your ratios, look at your relationships, and you can do it. Now, don't forget, sometimes you have to know you have to find the angles. This came up fourth period. Let's say I gave you, I don't know, let's say this is 120 and this is 30, and I want you to find that angle. Okay? It's the inverse of some trig function. Again, what two sides do I have relative to theta here? I have opposite and adjacent, so which of my trig ratios uses opposite and adjacent? Tangent. So I would say tangent of theta, that's the unknown, is opposite, over adjacent. Right? But how do you put that in your calculator? Do you remember?
The fraction. Like the 1 over.
No,
Oh wait, no.
isn't it
it's the inverse.
negative? Isn't it the tan negative?
Yes, you use that inverse tangent. So theta is going to be the inverse tangent of whatever that value is. Does that make sense? So just be aware, sometimes they're going to ask you for an angle. If you're solving for an angle, you're going to use an inverse trig function, the -1 ones. Okay? If it's a side, you don't need that. You just need the traditional sine, cosine tangents. All right? Practice these, get these down. Don't be surprised if you see them on the test and the quiz. So the rest of the period, you are